3.7 Human Interaction with Earthquakes. Can humans cause earthquakes? Yes, we can cause earthquakes by loading Earth's crust, as in building a dam and reservoir which fills up with water. The weight from water reservoirs may create new faults or lubricate old ones. In this picture is Hoover Dam and Lake Mead, which caused magnitude 5 earthquakes while filling. We can also cause earthquakes by injecting liquid waste deep into the ground through disposal wells. Liquid waste disposals deep in the earth can create pressure on faults. This also occurs with hydrofracking and enhanced oil recovery, both of which involve injecting liquid and/or supercritical fluids into the subsurface. We can also create earthquakes when creating underground nuclear explosions. Nuclear explosions can cause the release of stress along existing faults. Largest associated earthquake with nuclear testing is magnitude 6.3. 3.8 Minimizing the earthquake hazard. The focus of minimization of the earthquake hazard is on forecasting and warning. There is the National Earthquake Hazard Reduction Program. There are also several estimations of seismic risk. There are long-term predictions and forecasting and short-term prediction and forecasting, as well as some warning systems. The National Earthquake Hazard Reduction Program aims to develop an understanding of the earthquake source, determine earthquake potential, predict effects of earthquakes, and apply research results. For populated areas, agencies have estimated of seismic risk based on past earthquakes. Remember uniformitarianism, slip rates, how fast the plates are moving past each other, and fault displacement, how much the ground would be displaced if an earthquake did occur. Long-term predictions involve recurrence intervals, known as seismic gaps. As seen in this image, the rate of earthquake occurrence gives a rough pattern that can be used to determine a time frame, often decades, in which another earthquake of similar size is likely to occur. If the fault has not been active enough to provide enough historical data to determine recurrence intervals, often the geologic record must be used. This usually involves digging a trench across a fault to find sediment displacement and sand blowouts that indicate when an earthquake occurred. Short-term prediction involves detecting micro-earthquakes with magnitudes less than 2, land tilting due to the stress and strain, and foreshocks, all of which may occur before a larger earthquake. The land tilting and ground deformation can be detected via GPS and satellite image processing. There can also be geophysical and geochemical phenomena, such as changes in electrical resistivity of earth materials and changes in groundwater temperature, water levels, chemistry, and radon content. This is all due to fluids in the ground responding to stress and strain. The fluids, usually groundwater, move in response to the stress and strain, much like fluid moving in a sponge when it's squeezed. The electrical resistivity of earth materials change when the water content changes. Short-term prediction or forecasting is not reliable. We cannot say with certainty that an earthquake will occur soon, as in a day or a week. Long-term prediction or forecasting and estimation of seismic risk are useful for planning. Japan has a warning system in place that uses radio waves, which are faster than seismic waves, to shut down critical facilities, such as bullet trains, that could kill many people in an earthquake. The advance warning is not long, seconds to minute, and is sometimes a false warning, which can be annoying. 3.9 Perception of and adjustment to the earthquake hazard. Perception of and adjustment to the earthquake hazard requires efforts on both the community and personal levels. Community adjustments include the location of critical facilities away from active faults, which requires microzonation and detailed geologic mapping. Communities can also try to ensure structural protection so that buildings don't collapse in an earthquake. It's often said in earthquake mitigation, earthquakes don't kill people, buildings kill people. So earthquake-resistant design is critical to saving lives. Retrofitting of older buildings can also be effective, as well as general education about the earthquake hazard and mitigation strategies. Education can take the form of distribution of preparedness information, drills, and more. Other community adjustments can include increased insurance and relief measures, such as HAZAS and FEMA. Personal reactions and preparation can include: do a home inspection to make sure that your home is structurally sound. Secure large objects. Make a personal plan of how to react to a quake. Leave buildings and move to an open area after shaking stops. And turn off main gas lines. Personal adjustments include a home safety check, emergency plans such as drop, cover, and hold on, emergency food, water, medical, energy, cash supplies. Expect P, S, and then surface waves. And after shaking stops, leave the building. Watch for falling objects. Turn off main gas line. Remember, no open flames. And prepare for aftershocks. That's all for the earthquake slides. Next, we will be discussing volcanoes. Exciting!